कॉल करता हूँ उसको। टाइम भाई क्या।
अरे सचिन आ रहा है, मतलब
एक ही
सचिन
तू ही
का
कर
क्या है
पाना।
कि वो दूसरे लैपटॉप पे कुछ तो सेटअप कर रहा है, तो
हम्म।
वो ये लैपटॉप
हाँ
पे ज्वाइन
वॉइस आ
कैसे तो
गया
करें,
अभी।
पता नहीं, रुके क्यों।
अरे एक ही बोलो भाई।
एक एक लाइन रिपीट हो रही थी क्या अभी?
ओ सॉरी,
हो गया।
मेरा वो स्क्रीन पे
हेलो
आवाज
सचिन।
चालू हो गया था, एको हो रहा था। सॉरी।
हो गया अब शायद। हो गया। हेलो।
हाँ आ रहा अभी स्क्रीन पे, ऑफ करो और चालू। लेट हो
नाइस। भाई
आई थिंक
टाइम
सो
हो गया।
वॉइस हो गया।
हाँ हाँ
हाँ
भाई।
हो गया।
हाँ हाँ, ठीक है, तो फिर मैं
बढ़िया
अपलोड
कॉन्टेस्ट।
करता हूँ, ठीक है।
कर दे, हाँ कर दे।
जो
ए में किसी को डाउट है?
नो।
हम्म। ठीक है, एक
वेट
बार फिर
वेट
भी
वेट
एक्सप्लेन कर
वेट
देता
वेट।
हूँ।
अरे वेट वेट वेट,
प्रतीक, रुक
श्रीम
जा
और
रुक
वो
जा रुक जा रुक जा।
वो सब कुछ जाने दे।
मेरे को
लिंक
थोड़ा एक बार
सब
अपलोड
जाने दे।
करने दे, फिर चालू कर, ओके।
हाँ।
हाँ ठीक है।
बिकॉज डीएस में है ना अभी, मैम ने अलग ग्रुप बनवाया है, तो उसमें लोग आएंगे अभी बहुत ज्यादा। मतलब बहुत ज्यादा तो नहीं,
अलग
दस
ग्रुप
10
बनवा
जन तो
मतलब
आएंगे।
किस चीज
मतलब
का?
ओके।
मैम ने ही ग्रुप बना दिया कि सीपीडीएस से कौन करता है, तो वो ग्रुप अलग बना के ऐसा कॉन्टेस्ट दूंगा ऐसा।
तो
ओके।
मतलब शी इज प्रमोटिंग सीपी।
अच्छा, -10 हो गया। 5 मिनट रुकते फिर।
हाँ हाँ, ये लिंक आ जाने दे, लिंक फिर भेजता हूँ सबके।
ठीक है ठीक है।
फ्रेम का थंबनेल चेंज नहीं करे हो?
कर लेंगे बाद में, अब नहीं कर सकते वो।
ओके। होल्ड ऑन, अभी 2 मिनट रुक जा।
हम्म।
आदित्य नहीं दे रहा क्या?
नहीं आज नहीं दिया वो।
अरे ये अक्षत है क्या? वो डीएस वाला अक्षत है।
अक्षत किधर है?
ऐसा
Oh,
हाय
हाँ
hello.
हाय अक्षत, हाय 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 हाय। हाँ
The
हाँ, वही है
हेलो।
वही
lazy
है।
panda Deepak Mali. अरे crazy.
लेजी
क्या?
लेजी लेजी पांडा कौन है?
अरे
दीपक है।
दीपक भाई,
अच्छा, ओके ओके।
यूपीएस अड्डा ना भाई।
तरन है।
मैंने वो नहीं दे दिया उसने शायद।
गुड।
क्या?
अरे अरे।
हाउ वाज कॉन्टेस्ट?
फाइन, नॉट टू गुड।
हम्म। कर करो।
परम्यूटेशन वाला बाइनरी सर्च से किया ना?
क्या?
परम्यूटेशंस वाला बाइनरी सर्च से किया।
परम्यूटेशन देखना कौन सा? ओ वो बाइनरी
लास्ट
सकते
वाला।
हैं?
ओ।
नहीं नहीं। नेक्स्ट वीक से आई बी देयर टू टेकिंग पीसीडीज। इस वीक थोड़ा बिजी।
परम्यूटेशन
हम्म।
वाला साइकिल से किया था क्या?
हाँ साइकिल से किया था। फॉर
अच्छा।
ईच साइकिल
हाँ
यू
साइकिल से
बिल्ड द
किया।
आंसर।
आ ही नहीं रहा था फॉर्मूला।
हम्म।
साइकिल साइकिल्स वाला क्लिक हुआ पर फिर फॉर्मूला नहीं क्लिक हुआ मुझे।
फॉर्मूला तो वही है ना कि जितने डिफरेंट है विच इज लाइक साइकिल का साइज इंटू बी शुड बी लेस देन साइकिल साइज -1 इंटू ए, तो ही तुम बी लेगा ना।
हम्म।
हाँ वो बाद में डिस्कस कर लेते हैं, तो अभी लेट प्रतीक डू दी ऑनर्स।
यस, कर दे स्टार्ट। बाय बाय। ओके।
तुम लोग में से कोई यूट्यूब स्ट्रीम खोल के बैठा है क्या?
मैंने खोला है, क्यों?
नहीं नहीं, व्यूज ऐसे ही बढ़ रहे, मैं सोच रहा हूँ।
अच्छा ठीक है, चल स्टार्ट कर देते हैं मीन्स। ड्रॉ। ठीक है। ए में किसी को डाउट है? हो गया होगा सबसे। लिंक कर देते हैं फिर भी।
नहीं नहीं भाई, बड़ा बड़ा आगे बढ़ा, हो गया।
क्या?
हो गया मतलब
कर
डन
देता हूँ
हो
एक्सटेंड।
गया।
ठीक है, कर देता हूँ, 2 मिनट तो उठाइए। सो A में we are given two integers A and B, where A is the wait. Okay, so A is the orange syrup and B is the water. One parts and the water should be 5 or one. So how much orange juice can we possibly make for 5? So we cannot use all five. We will have to use four amount of water and two amount of orange juice to make it six. But the orange juice is only one. Amount of 10 amount of water, but we have only 5 amount of water. So the maximum amount of juice that we can produce is 6, 2 comma 4. Okay, so how do we approach this problem? So we can find minimum amount value of the orange syrup, comma the water divided by 2. So for this it is going to be 5 comma 2, and we can uh, this will be 2, and we can just multiply this by 3 to get 6. So that's what I did in my code. Is 3. That's it. Okay, let's move on to B. Okay, let's just discuss it. So B may we are given a string. Yeah, so B may we are given a string, a binary string, and in one operation, which is initially 0. Let's say this is the string. In one operation, we can turn three consecutive elements into one. For example, we can turn these three elements into one, or any of these three elements into one. We can turn any three consecutive elements into one. So we are supposed to find if we will be able to reach the given string in any number of operations. So let's take a test case. Okay, so for this, initially the string is 0, 0, 0, and 0, and we need to reach this string. So in the first operation, we can just turn these three consecutive elements into one, and in the second operation, we can turn these three consecutive elements into one to achieve the target. Therefore, the output here is yes. Let's take this string. So initially, all values are 0. So to convert, we need to convert these two elements into one. But there is no possible way to not convert this or this element into one along with this process. So it is not possible to convert only two elements into one. So there should be at least for this entire string, there should be at least three elements which are one and consecutive. In this case, there are only two elements. So we just output no here. that for all the subarrays, at max, uh, at least there should be three ones. Okay, so that's all in this. So I just did string dot pushback 0 to avoid to just count this as in case there is 1 at the end. Then we can just count this as it is between two zeros because I did string dot pushback 0. And if string equals 1, then I did count plus plus. Whenever I encounter a 0, and if of all ones is 1, then I just output no and I turn count into 0. That's it. If it passes through all of these loops, then I just output yes. Any doubts still here? Okay, we will start with the third question. थर्ड में डाउट है किसी को? हेलो?
नहीं
ओके, फट से कर देता हूँ. Okay, so third question में we are again given a binary sequence of length n and we construct an n into n matrix by this condition. Okay, I'll just take a test case to construct this matrix. Okay, so I just write it 3, 0, 1, 1. So to construct the matrix for this, so whenever this is I and this is j. So when we cell where I is greater than j, we put the value as the prefix as the summation of all values in this array to j. So for example, here I is greater than equal to j, so we can just put sum of all values from 1 till 1. These are the this indexing. So all sum of all values from 1 to 1, which is 0. Then again here we can just put sum of all values from 1 to 2, which is 1. And here we can also put sum of all values from 1 to 3, which is 2. Now similarly, whenever j is greater than I, we can just mirror this. So 1 comes here, 2 comes here. For this case, 2 comma 2, I is greater than equal to j. So we put all values in this. So 1, and here it is going to be 2. This is going to be 2 as well, mirrored because j is greater than I. And for this value, it is going to be 1 because I is greater than equal to j. So from 3 to 3, all values ka sum is 1. After this, we just have to find the minimum path from 1 comma 1 to n comma n. So the minimum path here can be achieved in several ways. We can go from 0 to 1 here, 1 to 1, then 2, and then 1. It is going to be 1 plus 2 plus 1 plus 2 plus 1, which is going to be 5, which is what we are supposed to output. Okay, so how do we approach this problem? So one thing to notice is that from any value, there is always going to be a symmetric value here. So if we start from 1 comma 1, we can take any path. We can either go 1 comma 2 or 2 comma 1. It doesn't make a difference. Okay. So the first thing to notice here is this, that I can't add comes here. Yeah, so the first thing to notice is that all diagonal elements will always be added. Comma n without visiting all the diagonal elements. We can go like this, but it is going to be a not an optimal path, because it is going to be there. We are going to encounter two twos and two ones. So the value would be 6 here. So we should be visiting all the diagonal elements. This is the first thing to notice. The second thing to notice is that since we are going to visit all diagonals, we are always going to visit them in a zigzag phase, like 0, 1, or we could also visit it like this. The answer would be same. So we can always visit the n comma n in a zigzag fashion. Values from 2 to 3. So we can just greedily add all the elements for each operation at each step. Okay, so that is what my code did. Yeah. Yes. Yes, बोलना. हाँ, great. Okay. TL क्यों आया था? यही है ना? या ऑर्डर चेंज हो गया क्वेश्चंस का? हम्म. क्या कर रहा है? ओके. तो भी वही सिमुलेट कर रहा है. हम्म. अच्छा, मतलब अगर फर्स्ट और लास्ट 1 होंगे तो फिर तो उनको माइनस कर देगा। 0 भी होंगे तो फर्क नहीं
फर्स्ट
पड़ेगा।
और लास्ट एलिमेंट 2 बार आएगा, बाकी सब 3 बार आएंगे आसपास।
मेक सेंस। सही है।
चलो भी एक करें।
अच्छा, मैंने बहुत कॉम्प्लिकेटेड सोचा, टाइम भी लग गया।
मेरे को ये करने में टाइम लग गया, तो पहले प्रीफिक्स ले रहा था तो उससे भी हो जाएगा।
डी में डाउट है किसी को? हो गया क्या सबका डी? डैम। चल ठीक है, स्टार्ट करते हैं। Okay, so D my question is, we are given a multiset which consists of n plus m strings, जिसमें n strings are just this and m strings are this greater than sign. Okay. And at each operation, we can compare these strings. So let's say the strings are this, this, and this. So we can just compare any of these strings in the lexicographical order, and we are given the lexicographical order of all of these signs. So where is it? Yeah, this is the smallest. This is this has ASCII value 61 and this has ASCII value 62. So for this example, we have to, let's say, okay, I'll take a shorter example. Let's say we only have these two strings. This is not there right now. So we have to compare these two strings. So this string is lesser than this string, and we make a new string and we delete these two strings. And this is the answer because we only have one string remaining now. Similarly, okay, sorry, this should be equal to because they are equal. My bad. So this is the answer. Let's take another example. Let's take this as one string and this as one string. So for this is lexicographically smaller than this. So we can just append this string to the multiset and delete these two strings. And this is the answer. What we are supposed to achieve is that we have to find this final string and it should be lexicographically the smallest achievable using all of these operations. Okay, so let's take a good example. Let's take this as an example. Okay, 2 and 3. So basically, currently we have this multiset. So what we need to consider is that we need as many less than signs in the beginning to make it lexicographically the smallest. So what we can do here, how can we achieve that extra less than sign? By comparing it with something bigger, any of these strings. So we can just replace this string and this string as less than is less than greater than, and the rest strings remain the same. Now, now we can further bring one more lesser than sign in the uh, to the left side of this bigger string. because this string is lexicographically smaller than this string because it is a prefix of this entire string. So we can just eliminate these two strings and write it as less than. This string is lesser than this entire string. Less than, greater than. And the rest of the strings remain the same. We can again do this because we have one more lesser than sign. Lesser than is lesser than this entire string. And this. Now we can just simply do this is lesser than this string. We don't have any other option. This is lesser than this string. And this is our final lexicographically least output. Okay. So there are several cases here. There are three cases here. So when can we encounter an equal to sign? Only when one of them is 0. Okay. For this example, we have this string in the multiset initially. And okay, sorry, this string, these two strings. So how can we, there is only one way to simplify this, right? We can just add an equal to in between, which is the output. Uh, so let us expand this further and let's take 0, 3. So for this, any two strings you consider, we are always going to get the same string because all strings are the same. So we can consider this string. And we also have this string. Now this string is a prefix of this string. So it is lexicographically smaller than this string. So we can simplify this like this. This string is lesser than this entire string. And this is the output. Okay, wait, what? Okay, this is the case, my bad. So let's expand this even further and try to find a pattern here. Let's take this 0, 4. So this is the multiset right now. We can simplify any one of the values because all are same. Now to make that extra less than sign, and this is the separate string. This is just one. It goes toward, and whenever we keep doing this, we need to take into consideration. The first condition is obvious. When both are 0, that is the multiset is empty. We don't do anything. And whenever, in this case, n is 0, right? So yeah, when n is 0, I output this pattern m minus 2 times. Is 2 and m is 0. So basically the multi-set is this. So there is a pattern using this. Now let's take more examples. 3 comma 0. So less than less than less than. So we first thing, obviously this is what we can do. Now this string is a prefix of pattern here. So whenever times does this pattern occur, basically n minus 2, because we use up two of the lesser than signs initially, multiplied by 2, because we keep comparing it as lesser than, and plus the number of times this occurs. So for I just ran a for loop and I outputted this, and towards the end this base condition. That's it. Now when n and m both are not 0, let's take anything 2 comma 2. So greater than, less than. So we are supposed to maximize the number of lesser than signs in the beginning to make it lexical. These are gone. Then we again compare this thing. So again there is a pattern here. So what we can observe is that this part occurs m times in the string. Okay, so here m was 2, and this pattern occurs m times towards the end. So less than, greater than, greater than. We compare this with this. Less than is less than this string. This is gone, this is gone, and we have the remaining strings. Then we again compare this with this entire string. So less than is less than this entire string. These two are gone. Now we have these three remaining strings in the multiset. Then again we do this. This is lesser than this entire string. And we finally compare this and this. So this is lesser than this string. 3, 4, 5, 2, 3, 4, 5, 6, 7. Yeah, okay. So how many times does this sign occur till here? Because we know that this occurs m times. One. from 3 and it occurs, how many times does it occur? 3 times, right? No, 2 times. Yeah, 3 times. 3 times from 2. So it is basically n minus 1 multiplied by 2 plus 1. These many times the lesser than sign occurs, and then this pattern occurs m times. That's it. So after this return, this is where n and m are not 0, this part. This string, and m times I output this pattern. That's it. Any doubts?
No, understood.
Yeah. Anyone wants to share their approach if it is different? Okay, no worries. Was anyone able to solve the fifth question? Or has an approach to share? Hello?
लाइव स्ट्रीम चालू है क्या?
Yes, चालू है.
मैंने तो यही सोचा था, लाइक साइकिल्स हम बना सकते हैं, लाइक अगर AI इज इक्वल टू चेंज होगा, वो साइकिल में चेंज होगा, और
अच्छा.
एक साइकिल सम लेट्स से के लेंथ का है, तो फिर उसमें हमें
हम्म.
K-1 बी ऑपरेशन लग सकते हैं, या फिर के
रुक रुक रुक, मैं एग्जांपल लेता हूँ जो कुछ समझ नहीं रहा. ये एरे लेते हैं 3 2 1 4. इसमें सॉरी वेट, कुछ और लेता हूँ थोड़ा इजियर. 2 1 4 3,
नहीं, वो
इसमें
वाला
दो
सही था,
साइकिल्स है.
चल। हाँ, ठीक है।
ठीक है. तो अब क्या करेंगे इसमें?
तो
तो
फिर
साइकिल लेंथ इज
इसमें
2.
एक तो अगर 2 लेंथ का साइकिल है तो हम एक बार ऑपरेशन करना पड़ेगा बी वाला, या फिर 2 बार ए वाला ऑपरेशन करना पड़ेगा।
दो
स्वैपिंग
लेंथ.
वाला एक बार कर।
स्वैपिंग वाला, हाँ स्वैपिंग वाला 2 बार करना पड़ेगा, राइट? इसके लिए
एक
और इसके लिए.
नहीं, एक साइकिल के लिए।
हाँ, हर एक साइकिल. ओके, इस साइकिल के लिए एक बार स्वैपिंग वाला ऑपरेशन, एंड चेंज वाला दो, हाँ 2 बार करना पड़ेगा, राइट? और
तो
उसका
फिर
कॉस्ट भी
हम,
होगा कुछ.
हाँ,
हम्म. इसका कॉस्ट होगा
फिर हम
2. इन दोनों का मिन. बस ऐसे फिर ब्रूट फोर्स मारना है क्या?
मुझे लाइक फॉर्मूला क्लिक नहीं हो रहा था कि ए और बी का वैल्यू क्या होगा एल लेंथ के साइकिल के लिए।
अच्छा. हम्म. मैंने इस पे पता है बाइनरी सर्च सोचा था. लाइक अपन ए को फिक्स करेंगे, ए पे ही आइटरेट करेंगे, एंड वी कैन फाइंड द बी का वैल्यू विच इज लेसर देन और इक्वल टू ए, और उधर तक फॉर्मूला बन जाएगा n इंटू एन प्लस 1/2 जितना भी है, एंड उसके बाद का सेम होगा, ए ही होगा. ऐसा मैंने सोचा था. सबमिट किया है क्या? नहीं, मेरा प्री टेस्ट ही रन नहीं हो रहा था, चला गया कोड।
जनरल जनरल ज्वाइन करने वाला है।
मुझे नहीं लगता। ठीक है, guys, फिर पीसीडी इज ओवर।